Hey guys, this is Miss Smith. Long time no see. I hope everyone's doing well during the quarantine. I am here to help review you for graphing and proportions. Remember, you can pause and rewind the video at any point if I'm going too fast or if you need to see something else done. Here we go. So first, let's remember that a proportion is two equivalent ratios. And so on the left, we have one of our just kind of standard proportions, and on the right, we have what are percent proportions. Now, when we solve proportions, we're solving for a missing piece, and there are lots of ways to solve a proportion. There is not really one right way. In my class, we talk a lot about, hey, let's work smarter, not harder, because I tell them, Miss Smith's a little lazy, and if I can do the least amount of work and still get it right, I'm all over that. So we look for relationships in the proportions. And so one relationship that we can see really easily here is to go from 2 to 10. Now, not everyone always sees the relationship, so there's other ways at work, but if you do, let's use it. So 2 to 10 is times 5. Well, anything we do to the top, we do to the bottom. We have to keep these equivalent. So 6 times 5 is 30, so x equals 30. There's actually another relationship here too. I can get from 2 to 6, which is times 3. And 10 times 3, what do you know? It gives me 30. Now, the one way that we know that it always works, but it doesn't always seem the easiest because of the amount of multiplication and division that you do. Okay, so that is where you cross multiply 2x equals, and you cross multiply the other way, 6 times 10. Well, 6 times 10 is 60, and that equals 2x. We're going to solve this just like we solved equation, guys. We got to keep them level. We're solving for the x, and we got to isolate that variable. We have multiplication over here, so we're going to divide by 2. Divide by 2. 60 divided by 2 is 30. We have 2x's divided by 2. That gives us 1x. So x equals 30. So I solved this problem 3 ways. Hey, you might even see another one, but be very careful. And sometimes it's so simple, we don't want to mess up. Also remember, if you're working with a proportion, because percent means per 100, a percent will always go out of 100. A 100 is our whole, so that's why our whole is our denominator. Now, as we look at things, always look at the big picture. Read, 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 annotate, annotate, annotate. So let's start with a bar graph. Now, a bar graph has lots of information, and you want to make sure that you read all the information that you can. One of the biggest things I notice here is that I have 7th graders and 8th graders. Even though they each fit into one of these, I have them both. So I'm going to start with the 7th graders. When I look at my bars, I'm going to try to label them the best that I can. So I'm going to say this one's 10, this one's 12, and this one is 3. So if I add these together, 10 plus 12 is 22, plus 3 is 25. So I have 25 7th graders. Now let me check out my 8th graders. So here I have 15. Here I have, looks like 7. And then I have 3. Well, I know 7 and 3 is 10. 10 plus 15 is, what do you know? 25. Now, it's good to know how many of each, but I also need to know the whole. So that means I have 50 students total. Well, let's say it asks us, what is the percent of the students that are car riders and 7th graders? Oh, that's a lot of information there. So I'm going to do line equals sign line 100 because it's asking for a percent. I'm looking for the percent of students that are car riders and they're 7th graders, okay? That are 7th grade car riders. So then that means over here I have to have 7th grade car riders. And then I have my total. So when I look at it, okay, what was my total again? My total was 50 students. How many of them were 7th grade car riders? 7. And this is my unknown, so that's where my x goes. So let's try to figure this out. We can solve this a lot of different ways. So I'm going to go ahead and go with my relationship because I want to work smarter, not harder. 50 times 2, what happened to that crazy 2 there, is 100. So 7 times 2 is 14. So 14% of the students are 7th grade car riders. Now, I could have done basically the same thing with any of those, just kind of looking for it. I could have even found the percent of 7th graders that were car riders, just looking at the 7th graders and car riders. This is all of the students, but I could have had 25 as my denominator. So next we're going to look at a circle graph. The one thing about circle graphs were new to us this year. Although you've seen them before, you haven't worked with them in the same mathematical way before this year. As we remember, a circle graph is 100%, always represents 100%. Now, the 100% could be a different number. It could be 50, it could be 25, it could be 3 million. And in this case, our 25% represents 2,000 calories. So as I look here, I can use that information to find a specific percent. So what I'm going to do is I'm going to find, let's go with veggies. Let's find out how many calories it is for veggies if they make up 35% of our daily intake. So line equals sign line 100, because I'm talking about a percent. The percent I know is for veggies. So then this label is veggies. Annotate, 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 label, label, label. Okay. And then over here we have our total. Now this is talking about calories. Okay. So our total calories, it's a 2,000 calorie diet. We know the percent is 35, but we don't know how many calories that is for the veggies. You can cross multiply and divide, or you can simply say, hey, look at this. If I multiply 100 by 20 and I multiply 35 by 20, I'm going to get x equals 700. 700 calories for veggies. Okay, set up a proportion, make your life easier. Now, you're like, Miss Smith, I'm just not getting these proportions. Okay, let's think of it a different way. Veggies is 35%. Percent is always out of 100. So let's break down that 100%. So if 100% is 2,000, then 10%, which 100 divided by 10 is 10%, and then 200 divided by 10, 2,000 would be 200. All right, look at that. I've already got to my 10%. And if I know 10%, I can get to 1% by simply dividing by 10 again. So 1% is equal to 20. Man, those alone give me so much. But I'm going to go ahead and figure out, well, what's 5%? Well, think, how do I get from 10% to 5%? Divide by 2. So 200 divided by 2 is 100. So this right here is enough to figure out every problem on here. So if I'm going to veggies, all right, so veggies is 35%, which is really 10% plus 10% plus 10% plus 5%. So whenever I add those up, those would equal 35%. So 10 and 10 and 10 and 5. So 10% was 200, 200, 200, and then 5 was 100. And what do you know? 35% equals 700. I get the same answer that I got on the other page. You could also look at it different ways. When I get protein, I don't have to add the 10 and the 10 and 25. I know 25% is 1/4. So I could take my total amount and divide it by 4 and get 500 for my 25%. You can do it lots of different ways. So this next one is going to be a dot plot. Now a dot plot is kind of like a bar graph. Don't make it harder than it is. I still like to go ahead and write the numbers on the top because it helps me be able to see it in a different picture. These are annotations, guys. Y'all worked so hard during the year with annotations. Let's not forget them. It's not because we're crazy math teachers who want to make you do more work. We're crazy math teachers who want you to do so much better. So when I look at it, I can be like, oh, look at this. So the number of TVs per household. Well, there are 5 people in this class that have 3 TVs. If I want to know, who has 4, how many people have 4 or more TVs, I could say, so 4 or more, that's 2, 3, 4. 4 people have 4 or more TVs. Now, the one thing you always want to find out is what's the total? The total helps you put things into relation. So I have, 2 plus that's 4. I'm going to add 4 to 6 and get 10. 3 to 7 and get 10. So that's 20. And then 5 is, the total is 25. Now that I know the total, if I needed a percent, set up a proportion. Line equals sign, line 100. Guys, I know you're going to rock this next assignment. It does involve a lot of reading. Now, don't let the reading steal your math, okay? Really stop, think about it, take some notes. I know that you're like, Miss Smith, I just want to, go through it, read it, and know. But hey, do well, do well. Don't let the reading steal your math. So you've got this, guys. You're going to do awesome. Have a great one. Bye.
Give me here.